What if Earth stopped spinning? Right now, you're moving at more than 1,600 kilometers per hour. You can't feel it. Your coffee doesn't spill. The trees don't shake. The buildings don't sway. That's because everything around you, including the air, is moving at exactly the same speed. Earth has been spinning for over 4 billion years, completing one full rotation every 24 hours. It's so constant that we rarely think about it. But imagine that somehow it stopped, not gradually, not over millions of years, but today. What would happen? Would gravity disappear? Would we be thrown into space? Could anyone survive? Let's find out. At first glance, Earth looks perfectly still. From space, clouds drift peacefully over blue oceans, while continents slowly rotate beneath the sun. But beneath your feet, the planet is anything but motionless. At the equator, Earth's surface races eastward at roughly 1,670 kilometers per hour. That's faster than the cruising speed of many commercial airliners. Even cities far from the equator are still moving incredibly fast. Johannesburg travels at around 1,400 kilometers per hour. London moves at nearly 1,000. Even near the poles, the ground never truly stops. We've simply evolved with this motion. To us, it feels like standing still. Now imagine that, without warning, Earth's rotation suddenly ends, not the orbit around the sun, just the spin. And that's when everything changes. The ground beneath your feet stops instantly. But you don't. Neither does your house, or your car, or the atmosphere. Every object not firmly attached to the planet continues moving eastward at its original speed. This is Newton's first law in action. Objects in motion stay in motion unless acted upon by an outside force. The result would be catastrophic. People would be thrown sideways faster than the speed of sound. Cars would become airborne. Buildings would collapse as everything inside them tears eastward. Entire forests would flatten. Steel bridges would twist apart. The destruction wouldn't resemble an earthquake. It would be more like the entire planet suddenly slamming on the brakes while everything else kept going. Near the equator, winds would exceed 1,600 kilometers per hour. For comparison, the strongest hurricanes on Earth rarely exceed 300 kilometers per hour. These winds would be over 5 times stronger. Concrete structures would fail. Glass skyscrapers would shatter. Anything not buried underground would likely be destroyed. But the atmosphere is only part of the problem. The oceans are moving too. Every drop of water carries Earth's rotational speed. When the planet stops, the water doesn't. Entire oceans would surge eastward across the continents. These wouldn't be ordinary tsunamis. Some waves could reach hundreds of meters high. Coastal cities would disappear within minutes. Islands would vanish beneath walls of water. Ships would be thrown deep inland before being swept back out again. The force involved is almost impossible to imagine. Water covering more than 70% of Earth's surface suddenly trying to continue moving at aircraft speeds. It would reshape coastlines forever. Then there are the fires. As debris races across the ground, power lines snap. Gas pipelines rupture. Fuel tanks explode. Vehicles collide by the millions. The intense friction from airborne debris could ignite massive wildfires. Entire regions would burn while hurricane-force winds spread flames across continents. Smoke would soon darken the sky. Surviving the first few minutes would already be incredibly unlikely. But the disaster has only begun. The planet itself wouldn't break apart. Gravity would still exist. Earth's mass hasn't changed. The planet has simply stopped rotating. In fact, many people believe we'd be flung into space. That wouldn't happen. Gravity is far stronger than the outward force created by Earth's spin. Even at the equator, that outward force only reduces your weight by about 0.3%. Without rotation, you'd actually weigh just a tiny bit more. Not enough to notice, but enough to measure. There's another subtle change happening beneath your feet. Earth isn't a perfect sphere. It's slightly wider around the equator because billions of years of spinning have caused the planet to bulge outward. If Earth stopped rotating permanently, gravity would slowly begin reshaping the planet. Over thousands of years, that equatorial bulge would gradually disappear. The oceans would move with it. Water naturally flows toward the lowest gravitational point. Without rotation, the lowest point would no longer be around the equator. Instead, enormous amounts of seawater would migrate toward the poles. The world map you've known your entire life would become unrecognizable. But that transformation takes time. The immediate catastrophe arrives much sooner, and it's still unfolding. Within hours, satellites begin failing because communication networks, power grids, and ground stations have collapsed. Air traffic disappears. Emergency services are overwhelmed. Cities fall silent. For those fortunate enough to survive the initial destruction, a much larger threat is approaching, one that no shelter can stop. Because although Earth has stopped spinning, it hasn't stopped orbiting the sun. And that changes everything. When Earth stopped spinning, the first few hours brought unimaginable destruction. Hurricane-force winds ripped across the planet. Oceans swallowed coastlines. Cities collapsed in minutes. But those events were only the beginning. The real challenge isn't surviving the first day. It's surviving everything that comes after. Because although Earth has stopped rotating, it is still orbiting the sun. And that single detail changes the fate of every living thing. Without Earth's daily rotation, there would no longer be a 24-hour cycle of sunrise and sunset. Instead, one side of the planet would face the sun continuously. The other would face endless darkness. But unlike flipping a light switch, this wouldn't happen instantly. Earth would still take an entire year to complete one orbit around the sun. That means every location would experience roughly 6 months of daylight, followed by 6 months of night. The concept already exists near the poles, where regions experience the midnight sun and polar night. But on a motionless Earth, this would become the new normal, almost everywhere. The familiar rhythm of mornings and evenings would disappear. Time itself would begin to feel different. At first, the daylight side might seem like the lucky side. After all, it still has sunlight. But the sun never moves across the sky. Hour after hour, day after day, week after week, it simply hangs overhead, pouring energy onto the same land without pause. Temperatures begin climbing. The ground absorbs more heat than it can release. Lakes shrink, rivers evaporate, soils dry and crack. Forests become fuel waiting for a single spark. Inland temperatures could soar well above 70 degrees Celsius. Some computer models suggest that regions directly beneath the sun could become even hotter. Much of the surface would become hostile to complex life. The landscape would slowly resemble the hottest deserts ever known, only far more extreme. Meanwhile, the night side suffers the opposite fate. With no sunrise to replenish warmth, temperatures continue falling. first below freezing, then far below anything experienced on modern Earth. Eventually, much of the atmosphere's water vapor freezes out of the air. Snow falls, ice thickens, glaciers spread across continents. Some estimates suggest temperatures could plunge below -100 degrees Celsius in the darkest regions. Entire oceans would begin forming vast sheets of ice from the surface downward. The longer the darkness lasts, the thicker those frozen layers become. Cities buried beneath snow and ice would eventually disappear from view altogether. Between these two extremes lies a narrow band circling the planet. Astronomers call it the terminator, the boundary between permanent day and permanent night. Here the sun would remain forever low on the horizon. Temperatures might be cool enough for liquid water, not scorching, not frozen, just survivable. If humanity had any hope of rebuilding, this twilight zone would likely become our refuge. Billions of people would attempt to migrate there, but reaching it would be another matter entirely. Roads would be destroyed, fuel would be scarce, food production would have collapsed. Most governments would no longer exist. The largest migration in human history would unfold across a devastated planet. And many would never make it. Nature would struggle just as much. Plants depend on regular cycles of light and darkness. Without them, ecosystems begin to unravel. Many crops would fail within a single growing season. Animals that rely on daylight to hunt, migrate, or reproduce would become disoriented. Bird migration patterns would collapse. Coral reefs, already sensitive to temperature changes, would suffer catastrophic bleaching on the sunlit side. In the frozen hemisphere, most ecosystems would simply cease to exist beneath expanding ice. Food chains built over millions of years would unravel in only a few seasons. The mass extinction would rival the greatest die-offs in Earth's history. The oceans wouldn't escape these changes either. Today, Earth's rotation helps drive powerful ocean currents that transport heat around the globe. The Gulf Stream, for example, keeps much of Western Europe far warmer than it otherwise would be. Without rotation, many of these currents would weaken dramatically or disappear altogether. Heat would remain trapped on the daylight side. Cold would remain trapped in darkness. The climate gap between the two hemispheres would continue growing wider every year. Marine life would struggle to adapt. Some species might survive near the twilight waters. Many others would vanish forever. The atmosphere would transform as well. Instead of familiar weather systems moving around the globe, enormous air currents would constantly flow between the hot and cold sides. Hot air would rise over the sunlit hemisphere. Cold, dense air would sink over the frozen hemisphere. Where these air masses collide, colossal storms could form almost continuously. Imagine hurricanes, only stretching for thousands of kilometers, lightning flashing across entire horizons, cloud systems visible from space that never truly disappear. The weather would become permanently violent in many regions. Yet, despite everything, humans are remarkably adaptable. Those who survived might build underground cities within the twilight zone. Geothermal energy could provide heat. Solar farms on the daylight side could generate enormous amounts of electricity, transmitted back to settlements through long-distance power grids. Frozen regions might become natural freshwater reserves. Advanced agriculture could move indoors, using artificial lighting and controlled environments. Life wouldn't resemble the civilization we know today, but it might continue. Humanity has survived ice ages, volcanic winters, and countless natural disasters before. Given enough time and technology, we would probably try again. There's one final question. Could this actually happen? The reassuring answer is almost certainly no. Stopping Earth's rotation would require an unimaginable amount of energy, far more than humanity could ever produce. No known natural process could suddenly bring an entire planet to a complete stop. Even massive asteroid impacts would change Earth's rotation only slightly. The laws of physics protect us from this nightmare. Our planet will continue spinning tomorrow, just as it has for billions of years. And that's something we can all be grateful for. Earth's rotation is so constant that we almost never think about it. Every sunrise, every sunset, every gentle breeze, every ocean current, every living thing has evolved around this invisible motion. It's one of the quietest forces shaping our world, and perhaps one of the most important. Sometimes the greatest wonders of our planet aren't the things we can see. They're the things we never notice at all.